everyone, if you're watching this video, then that means you've had some time to work through this lesson note. And by working through this lesson note, I don't mean that you just read through it, but rather you are an active participant. And by that, you read each example, attempted that example, and then looked through the solution. As well, you spent time trying to pull information. What was the key pieces of information that we should be taking from this note? And part of the reason why I give you this lesson and as a set note is to prepare you for those going away to college or university, that if your professor gives you a textbook reading or a set note to learn from, that you're able to pull key information from that note and not just get what I like to call highlighter happy, of where all of a sudden now your entire page is highlighted because you're highlighting as you read and you're going, oh, this is an important piece of information, so you start to highlight it. But rather, if we look at the note, we read through it, and we actively attempt the questions, then we can start to decipher between what information do I know and what information do I need to make a note on or highlight so that I can reference back to it again in the future. So let's go through this note with that in mind. So your prof has given you this note, and what you notice is that they have included something in their own writing, which probably means it's something important.
If they've included something in their own handwriting, that's telling us that that's something that they want us to know, and it's in addition to the information that's being given to us already and provided in these examples. So what you see there in writing is the amplitude of a function is half the distance between the max and the min values. So we know that the amplitude is half the height of our function, and the amplitude is the a value. And you'll recall that the amplitude exists for our sine curve and our cos curve. We have an a value for our tan curves. However, we do not describe our a value as the amplitude for tan because, as we discussed the other day, tan has no maximum or minimum value. The next piece that we see is the period of a function is the horizontal length of one cycle. Well, I'm going to circle this or put a box around this. Period equals 2 pi by k. That is a tool that you have, kind of your best friend that you have, that can help to remind you of the period of our function, okay? So if you'll recall, the period is how long does it take to complete one cycle. So when we think about that, we're thinking about, okay, how long does it take to complete a full pattern? Sometimes that might be a full rotation, okay? And we notice that the period is equal to 2 pi divided by k. And again, it's 2 pi when we're thinking about sine and cosine curves, because their base function takes 2 pi to complete an entire circle. You'll recall in tan, it takes pi units to go through to complete one cycle. So now that we've taken some time to look over the handwriting that the prof included, which means, okay, those are probably some key pieces of information that we needed to take note of, we can start to go through our next examples. So as we go through these examples, we want to be asking ourselves, okay, why did my prof include these examples? What am I supposed to get out of each examples? Because I can tell you next year, your prof isn't going to give you more examples than you need. They're going to give you a progression of examples, and then they're going to send you on your way. So we really want to make sure that we can draw as much information from the progression of the examples that we're given. So what we notice in this first example is we have state the domain, range, and phase shift of the cycle. So we're noticing that that's some key pieces that we're being asked in these questions, and that we should be able to do those just by looking at the equation. We should be able to state them. So before you continue on in this video, I want you to ask yourself again, did you work through each problem? Have you been active so far in this lesson in terms of you looked at that equation, you've been asked to sketch the graph, have you gone through and sketched that graph? Or are you just passively reading through these examples, right? So if you haven't taken an active role yet in this lesson, I want you to pause the video and go back and look through and work through those examples. Okay? Working through them is really going to help you understand what do you know and what are you still learning. Okay? Okay, so if you have been active during this process, let's continue on in this video. All right. So when we look at this first equation, we're noticing that this first one is probably just an intro into our lesson. Okay? So when we start with a lesson, we often try to, in order to acquire new information, we have a starting point that links to something we already know. Okay? So here we see that we have a vertical stretch by a factor of 1/2, and that we have a phase shift to the left pi by 2. Right, so this is just our intro question. So we should be okay to tackle that one with our vertical stretch and our horizontal shift. As we move into question 2, we should be asking ourselves, why did they include this problem? So when you look at problem 2, so right away when it's asking you to sketch one cycle of the graph, what in problem 2 is different than in problem 1? And what we should be noticing is we have this 2 here. And it's written inside of our angle. So we notice that we have a horizontal stretch. And we'll recall that it's a horizontal stretch by a factor of 1/2. And so where sine curve used to take 2 pi, it will only take pi to complete one full cycle of our sine curve. So again, a little reminder of that friend of yours of 2 pi divided by k. Well, we know that our k value is 2, so 2 pi divided by 2, our period would be pi. So again, just an extra resource that you have available to double check what the period of that would be. So then at that point, we know that we have a vertical stretch, a phase shift, so that's continuing on from question 1, but now we've been introduced to this horizontal stretch by a factor of 1/2. So we know that that again is going to change the period of our function, and then you should be good to go with that. So now we want to move into examples 3 and 4. So if we examine example 3, we start to just look at what does that equation have, what's different about this question than our previous questions, and we notice that we have a reflection in the x-axis. So where sine curve starts in the middle and rises, so normally where our sine curve starts in the middle and rises, we know that it will now start in the middle and fall. Right? So that's the progression we see in our example 3. And then lastly, when we look at question 4, we want to be asking ourselves, okay, so why did they give us question 4? Why is your prof asking you to spend some time on question 4? And so we notice, okay, we have a vertical shift. So that's a progression of this question. I think we all be okay with our vertical shift. And then when we look at, we should be looking inside of our angle, and we notice we have a 1/2 x plus pi by 2. The 1/2 is our k value, or our stretch factor. And so we know we have a horizontal stretch by a factor of 2. But you'll notice before we can do a phase shift, we want the coefficient of x to be a 1. The 1/2, that k value or stretch factor, has to be applied to everything on the function in order to have our phase shift. So what I need to do is I need to make sure that I common factor that out of each of those terms, again, so that I have the 1/2 is being applied to all parts inside of our angle in order for me to have that phase shift. So when I common factor out that 1/2, I might say to myself, okay, that's going to be pi by 4 minus 1. And I want to pause you at this point if that is what you've written, because we've just made a common mistake. Okay, what's nice about the fact that you've been active in this process is that you've now made that common mistake and that we can fix it and correct it for the next time we do a question like this. And so we can tell by, if I were to expand back in, that would give me a pi by 8, which we notice in our original function is not equivalent. So we can cross that guy out, and I'm just going to come over here. And so what I would encourage you is to maybe think of it in a different way. So we've common factored out our 1/2. I know I have 1/2 times x gets me back to my 1/2. And when you go to expand, that you're asking yourself, what times 1/2 will get me to a pi by 2? So we should have a phase shift, right, of pi units, and then our vertical shift down. And lastly, what you might have noticed, the difference between question example 3 and example 4 is in example 3, we're being asked to sketch from 0 to 4 pi, whereas you'll notice in example 4, the domain has changed and they're now asking you to graph within negative 4 pi to 4 pi. So just some extra minor details to be aware of. And as I mentioned in class, you will be provided with grids when you're being asked to graph with a domain of 0 to 2 pi. So we will ask you to graph that function within 0 to 2 pi. So sometimes that might mean you have more than one rotation. Sometimes that might mean you have a quarter or a half rotation that fits within 0 to 2 pi. So that is where we are moving towards. And then our next lesson, we will also be moving towards sketching our graphs of sine and cos on an axis. So we want to become very familiar with these transformations. And then we will be working towards graphing these on grids for our reciprocal and our tan functions. So that's where we're moving to with this information. We can always use Desmos Graphing Calculator when we're completing our practice to double check that we have in fact graphed our functions correctly as well. So just to recap for today, when you are provided with a written note, a set note from a teacher or a prof, you want to be as active as you can be. This way you tackle the question before reading through solutions. This lets you make your common mistakes and see where you are at with the material. This will also allow you to be more efficient when completing your practice because you've been active in the process. And then you're really able to also consider, why did they select those questions? What was the importance of each question, right? If we can take out the key important pieces of information, then we can avoid the page upon page of highlighted information, okay? We want to be able to take out that key information so we have something to reference back to if needed. And lastly, I'm hoping today's lesson will also just remind you that to look for any prof notes in there, right? If they've taken the time to write something additional on that page, it probably means that it's some really important information to be working with. So, hopefully today's lesson, since it was review material, I'm hoping you were able to learn a bit about study skills and about how to be an active learner when you're given a set note, and how you can draw out the most important pieces of information and how you can identify the progression and purpose of each question that you've been given. So you have practice questions posted that you can work through, and I am available to answer any questions that you have. Have a great day.